Welcome to this lesson on balancing equations. Okay, this is a new topic, completely new. And for some students, this will be a bit of a challenge, but I really encourage you to focus, pay attention, and watch the video over again if you have to, especially when I get to the examples. It'll come in really handy. All right. So far with chemical reactions and equations, we've looked at the reactants and we've looked at the products and we looked at those two things. And then we looked at different types of equations. Well, now we're going to move on to balancing them. And we haven't done anything with respect to this yet, but this is a little bit new, but you'll get what where I'm going with it as we move through the lesson, okay? So first of all, balancing equations is based on something known as the conservation of mass. What we can't do in chemistry is we just can't make things up when we're talking about a chemical equation or a chemical reaction. So the number of atoms that we have on one side of the equation has to be exactly the same as the number of atoms we have on the other. And it has to be the same types of atoms. We can't just go messing around changing that. So essentially, the mass of things here will equal the mass of things over here. So on both sides of the equation, it'll be the same. So this means that the number of each type, every type of atom in an equation, must be equal on both sides of the equation. Okay. Now, we can look at every single equation that exists and see how it works. So if I look at a pretty simple equation, and imagine this equation here that I've got, which is carbon, and actually this is carbon solid, okay? So carbon does come in a solid form, and you can combine it with oxygen, okay? So solid, and this is a gas, okay? And it will produce a gas called carbon dioxide. Now, what we can do is look at the product reactants and products in each component. For example, take, for example, carbon. I usually just use a symbol. On this side of the equation, how many carbon atoms do we have? Well, we have one. So that one carbon atom is over here. Well, what about on this side of the equation, on the product side of the equation? Well, we have one as well. And that means it's balanced. Both sides have the same number of carbon atoms. We have to do that for each atom. So let's look at the second one. The second one is oxygen. Okay, that's the only other atom that's in here. Well, oxygen has two. There's two oxygen atoms here. So on the reactant side, we have two. And on the uh, product side, we also have two. So that gives me two atoms here. Now we can say this equation is balanced. We didn't have to do anything. It was just naturally balanced. But that's unfortunately not how most chemical reactions occur, okay? Or equations, whichever way you want to call them. So let's look at another one that we're pretty familiar with in the formation of water. We've used this before. H2 plus O2 equals H2O. So let's try and balance this one out. What we do is we say hydrogens. Well, look at on this side we have two hydrogens, okay? And that's because H2 would be two atoms of hydrogen. And then we look over on this side, we have H2O. Well, that means we have two hydrogens here. Looks good to me. Everything's fine. Well, now let's look at the oxygens, okay? Oxygen, two right here, O2. Okay, that's good. And then we look over here and we go, uh-oh, we only have one. Well, that's not going to be good because the equation is not balanced. We don't have the same number. We have four atoms over here and we only have three here. What happened to the other one? You just disappear? No, it can't work that way. Now, sometimes students will go, well, let's just cross off this two here, get rid of it. We'll just call this O by itself. Well, you can't do that. You're not allowed to change the molecules that you have. Otherwise, you're changing the reaction. That's not allowed. So let's erase that cross off here. Sorry, erase that so that's not there. But what we can do is we can place numbers in front of these things, and we call these coefficients. So what I'm going to do is I'm going to actually place a 2 in here. And I'm going to say we're going to have two water molecules that we're going to create. And we call this here a coefficient, okay? That's what it's called. It's just a fancy word for a number out in front of the atoms or molecules, okay? But what it does is it makes two of these, two whole things of this thing here. Well, that changes things. First of all, now instead of having one oxygen, we're going to have two, which is great. Now we've balanced our oxygens. But look, as I did that, I said I have two hydrogens in the first place, and now I double it. Now I have four. That's not good because now my hydrogen's not balanced. My oxygen is, but my hydrogen is not. Well, that's okay because now I can go back and say, well, what if I put a 2 in front of the hydrogen here? That would change this to 4. Now I have 4 hydrogens on each side and I have 4 oxygen atoms on each side and everybody's happy. And so this is how we write this equation. So I'm just going to kind of erase some of the stuff here. This is how we write this equation. We say we take 2 hydrogen molecules, will react with 1 oxygen molecule to make 2 water molecules. And we are all done. Everything is balanced and happy because we have 4 hydrogens on this side, 4 hydrogens here, 2 oxygens here, 2 oxygens there. And that is what we refer to as a balanced equation. Now, there's a series of steps, and lots of people like to get into doing this, and I get it, it makes sense, and some students really like this, but at the end of the day, I find practice makes a lot of sense. But here's the steps that you can follow to help you do it. It says find the number of atoms in each element for each element of the reactants, and then the products. Pick one element and balance it by changing the coefficient, the numbers out in front. Then you recount the elements. Pick an element and balance it by changing the coefficient and recount again until we get balanced. We just keep repeating steps 4 and 5 and 6 again and again and again until we get it done, okay? And that's what I was essentially doing here when I did that. Just a more simple one than some of the ones we might do. So I'll try a more difficult one. Now there's a couple other pointers that are worth noting, is that balance elements that are listed only once on each side first. It just seems to make life easier for if you do that. And change only coefficients, never change the in front of the compound, never change the subscript, the numbers behind those little tiny ones, okay? And then this is a really important one, is treat polyatomic ions like, sulfate or nitrate like an atom rather than separate elements. So treat them like a unit of an atom. And then always check your final answer, okay? So let's do a few examples. I think I got 4 examples, and then I'm going to give you some questions to work on to practice balancing equations, okay? So let's try this one. The very first one, sodium chloride. Now, I'm not giving you a table every time, but I'm going to do it like this. It doesn't really matter which one you start with in this case, almost any case. I usually just work right from left. So I take the element that I see first, and I say sodium. And then I draw a line right where the arrow is on the equation, okay? And I say to myself, how many sodium atoms do I have on this side? Well, I have 1, NaCl, just 1. And then I say, how many do I have over on this side? Oh, I have 1. Perfect. That's done. No change required because it's already balanced. Then I say, let's look at chlorine. How many chlorines do I have on this side? I have 1. How many chlorines do I have on this side? I have 2. It's not balanced. I have 2 here and only 1 here. So this one has to go up. We don't cut them in half. None of that stuff. We always go up. So I'm going to put a 2 out in front of here, and that's going to change this to 2 chlorines. But you'll also notice that, oh no, it also changes the sodium to 2. So now I have to go back and look at how can I balance. I balanced my chlorines. I got 2 chlorines here, and I got 2 chlorines here. Now I have to go back and balance my sodium. I have to go back up and do that. Well, I got 2 sodiums here, so what do I have to do? I have to put a 2 in front of here, and that will balance it so that there's 2, 2, 2, and 2. Everybody's 2, everybody's happy, and we're nicely balanced, okay? All right, let's move on and try another example, okay? I'm going to be honest, the best way to learn these is just lots of practice and kind of follow the steps that I'm demonstrating. I think it really does help, okay? So here we go. We got nitrogen, hydrogen, oxygen. Nitrogen, oxygen, hydrogen, oxygen. Oh boy, it's kind of a messy one here. So let's take a look and see what's going to happen. Let's start with nitrogen here, okay? How many nitrogens do we have here? We have one on this side, and we'll draw the line in the middle. And how many on this side? One. Now let's do hydrogen. How many do we have? One, two, three, and that's it. And how many on this side? Oh, we have two. That's not balanced. But let's look at our oxygen at the same time. Okay, oxygen. And then we have two on this side. And then we have one, two on this side. Okay, so we only have one thing that's not balanced. The oxygens are balanced and the nitrogens are balanced. Unfortunately, usually when we throw one of these off, another one goes with it. So in order to fix this, this is really getting complicated because look at here. I got two hydrogens in here. The only way I can do that is make that a 2. That'll make it a 4. And that's not going to work for me because I can't just increase this one. So when I have a situation like this and I have a 2 and a 3 in the back, it's sometimes good to use that sort of trick crossover method. So what I'm going to do is I'm going to put a 3 here, and that's going to give me how many? 2 times 3 is going to give me 6 here. And then I'm going to do a 2 on this side. And I'm going to have 2 NH3s, which is going to give me actually 2 of them, which is going to give me 6 as well. Okay, we call that sort of that crossover method. We're just swapping over sides. Okay, now what I'm going to do is I'm going to see that things have probably changed for my other elements. So let's go take a look. For example, on this side now, I don't have 1 anymore. I have 2. And how many do I have here? Oh, I still have 1. And how about my oxygens? Well, over here, I got 1, 1, and 3. I'm up to 4. Uh-oh. All right, so my oxygens are out of balance, and so are my nitrogens. So now what I'm going to do is I'm going to just pick one. It doesn't really matter. I'm going to pick the nitrogen and balance it, okay? So in order to balance the nitrogen, I am going to say, oh, I have to increase this to 2, okay? And that will give me a 2 here in front. Now I have 2 oxygens and 1, 2, 3. Uh-oh, I have 5 oxygens. Oh, I can see this game is going to get played over and over and over again, but that's the way it works. Now I need to get my oxygens up. Well, how the heck do I bring my oxygens up to balance it with 2 and 5? Well, what I can do is I got to bring this up a whole bunch. And there's kind of a trick that I can do here is what if I said I took this to 10? I can't get to 5. So I just take 2 times 5 and I say I'm going to make this all the way to 10. I'm going to cheat. I'm going to make it 10. So I go like this and I go 10 oxygens. Okay. Oh, I apologize. Sorry. I'm going to make it 5 so that it makes it 10. Okay. So I'm using that crossover method thing again, right? And this is going to make this now 10, right? And what I'm going to do, oh, excuse me, bring this back up. What I'm going to do is I'm now going to increase the ones on this side so that I double them, right? So this was at 5. I'm going to double both of these to get to this so I can make this oxygen 10. So if I want this oxygen to be 10, I need to double both of these, okay? And this is a tricky one, really tricky one, okay? I don't even know if I'll put this one on your test. I want this 10. So I'm going to change this to a 6. And I'm going to change this to a 4. So remember, this is going to become a 4, and this is going to become a 6. Now I have 4 here, and I have 6 there. That gives me 10 oxygens. I got 5 times 2 here. That's 10. Now I got to go back and rebalance some of the other stuff. So first, let's look at the nitrogens. How many nitrogens do I have? Well, I now have 4 nitrogens. In order to have 4 nitrogens over here, this is going to have to increase to become a 4. Okay? And now I can look at my hydrogens. So that's 4. My nitrogens are now balanced, 4 and 4. What about my hydrogens? Well, I have 12 hydrogens right here, right? And 6 times 2 is going to be 12. And what about my, let me get back to here, apologize. So that was 6 times 2 gave me 12 hydrogens, okay, right there. And then how many hydrogens do I have here? Well, 4 times 3, that's 12. And now it looks like I'm balanced. 4 and 4, 12 and 12, 10 and 10. And these numbers here are what balance my equation. So let's just double check. Nitrogens, 4, yes. Nitrogens over here, 4, yes. Okay, 4 right there, nitrogens. Then maybe I'll put my highlighter on so you can see me better. 4 nitrogens, 4 nitrogens. How about my hydrogens? 4 times 3 is 12. That's what I've got. 6 times 2 gives me 12 hydrogens here. And then I go to my oxygens. I got 5 times 2 is 10. And I got 4 oxygens here and 6 more here. That gives me 10. And so I have it balanced. So I'm going to have 4 NH3s, going to go with 5 oxygens to make 4 NOs and 6 H2Os. And I'm all good, okay? And if I wanted to, I could use proper terminology. 4 nitrogen trihydrides plus 5 oxygen molecules plus 4 nitrogen monoxide and 6 dihydrogen oxide. Okay, if I wanted to use the proper language, but sometimes it gets confusing for students when I do that, so just keeping it simple works. Okay, erase some of my palm dots and we'll move to another one that's even more tricky, or a little bit more tricky, right? Got a couple tough ones here. Got to do the hard ones too, okay? So let's start with zinc, okay? Now, before I begin, I want to point out something. This particular question has what we call polyatomic ions. And if you're familiar, you notice that you see nitrate. This is nitrate here, NO3. And what I'm going to do is I'm going to treat nitrate like as if it is a atom. So it will get its own category here. So I'm going to do zinc, then I'm going to do silver, and then I'm going to do nitrate, NO3. And I'm going to look at the total number of nitrates on each side. And I can do that with these polyatomic ions. It really does work. There's the odd time that it doesn't work at all, and you got to be careful. But for the most part, it really works well. Okay? So draw a line down the middle here. Get my pen working. Okay? Zinc. 1 on each side. Oh, yeah, I like that. I always like it when they line up perfectly. Okay? So I'm going to say 1 on each side. Then silver, 1 here, and oh, look at that, 1 there. That's beautiful, beautiful. Okay, NO3. Oh, there's 1 NO3 here. Oh no, there's always got to be 1 bad guy. NO3, 1 here, and 2 on this side. So to fix this, I have to put a 2 here, and that's going to give me 2 NO3s here. But it's also going to increase my silver, my Ag, which is silver, up to 2 as well. So I'm going to put a 2 there. It's now out of balance. Well, I can fix that by simply putting a 2 right here. Now that's balanced as 2. Oh, it looks like everybody's balanced. Is it correct? Zinc has 1 and 1. Yep. Silver has 2 and 2, so it's balanced. And NO3, there's 2 NO3s here, and there's 2 NO3s here. So we are all balanced, all done, ready to go. So that one was actually easier than the last one, which was a real tricky one. Just kept you going and going. This one, it fixed itself pretty quickly. And you just never know with these balancing equations. Sometimes they work out fairly fast, and sometimes they take a little longer. All right, so let's go to our last example on the lesson, and then I'll turn you loose to do some practice, okay? So again, let's list our substances that we have in here, our molecules. We have calcium, we have chlorine, we have sodium, and we have PO4, which is phosphate, and that is a polyatomic ion. So I'm going to keep it together as one unit. I'm going to keep it condensed. I'm not going to separate it. You could go, oh, so many P's and so many O's and stuff. But generally speaking, you can get away with keeping it as one unit. It just makes your life a lot easier if you do that, okay? So calculate the number of calciums on each side. Oh, one on this side. That's nice and easy. One calcium here, none in there. Oh, and, oh no, three here. Okay, so we're not going to be balanced right away. That's okay. Chlorine, we got two here. Two chlorines here. How many? Oh, one over here. Okay. Yeah, I can see this is going to be a bit of a battle. Okay. Now we got sodium. We got three sodiums here. Oh, we got one over here. Nobody's balanced. Oh, this silly thing. And then I've got one phosphate here. And I got two over here. Okay. So I'm going to start balancing, and it doesn't really matter which one I start with, but I'm going to choose to start with calcium. I'm just going to work my way down and see if I can get this thing balanced. So the first thing I can do is balance the calcium. Well, I have three here on this side and only one here. So that means where the calcium is, I have to put a 3 out front, cancel it, put a 3 here. Now I have 3 calciums on each side. Perfect. Oh no, that changed my chlorine. Well, let's do our chlorine. Now I have 3 times 2 chlorines. That's going to be 6. And my chlorine's not balanced here. So to balance this with 6, I'm going to have to add 6 here. And that's going to be 6 now. So 6 chlorines and 6 calciums. But that changed my sodium. Okay. So now my sodium is 6 when it was 3. So that means this is going to have to become a 2 to become 2 times 3. And that's going to give me 6 sodium here. How many do I have on this side? Well, I have 6 as well because we put the 6 in front for the chlorine. They're balanced, okay? And then last but not least, I've got my phosphates to deal with. Sorry, somebody's trying to phone me and I don't even know who it was. All right, so now I have one phosphate on this side here times 2, so that makes for 2. And I have a 2 phosphates right here. Oh, that's already 2. Oh, it looks like everything is balanced, but I need to go back and double check. So let's just double check everything. Always do a double check at the end. So 3 calciums here, 3. 3 calciums here, yep, that's 3. Then I have chlorine. I have 2 chlorines times 3 makes for 6. How about over here? Oh yes, 6 chlorines, 6 times 1. That gives me 6 chlorines. Then I have sodium. Sodium, 2 times 3 is going to give me 6 sodiums. And then over here, 6 sodiums. And then last but not least, my phosphates. I have 2 phosphates here, and I have 2 phosphates here. They are all balanced. And so the numbers that I'm looking for are 3, 2, and this would technically be 1 if you wanted to write it in, and 6. All right? So I'm going to leave you with a whole bunch to practice. This is something that, if you don't practice this, you will not get very good at it. So yes, there is a number of questions here. I think I've got like 16 of them for you to work on, and we will take them up in one of our teams meetings. And this will be, for grade 10 math, this is the sort of culmination of what you're really learning with respect to chemistry. So I hope you enjoyed the lesson, and look forward to seeing you again soon.